So let's start talking about factorization of linear expressions. It's really the sort of the opposite thing to do when we are trying to expand. So let's just think. So if we have a number like 2x plus y, an expression 2x plus y, we can expand it. And if we expand it, so this is an expand. If we expand, we get a number like 2x plus 2y. And now what we can do is we can bring it back, and if we were to bring it back, we call this factorize. So if we try to factorize the expression 2x plus 2y, what we're doing is we are picking out as many common things as we can, and we'll get an answer 2y, 2 a multiple of x plus y. So if somebody asks you to factorize 2x plus 2y, you can say 2x plus 2y can be factorized into 2 times x plus y. You're converting it into 2 factors, as few factors as possible. So now let's think about a number like maybe 8x plus 12. So clearly, by using the distributive law, I can take 4 common. If I take 4 common, I'll be left with 2x plus 3. So that's called factorization. And if I have an expression like maybe minus 24 az plus 4ay, I can take 4a to be common. If I take 4a to be common, so 4a would be outside the parentheses, then from the first term, I'm going to be left with minus 6z, right? Because 4a multiplied by minus 6z will give us minus 24az. And from the 4ay, I'm only going to be left with a y. The answer is going to be this expression. So you can see that, and the idea is that you want to pick out as much as possible. So I could have even written it out as 4 times something, and then you'd get a minus 6az plus ay, but I should pull as much out of the 2 terms as possible, and 4a was the most common things that I could pick out from these expressions, okay? So now let's try another example. So if I try another example, let's look at an example like minus 6a minus 24az minus 4ay. So clearly you can see that if I look at the terms, you have 6, you have 24, and you have 4. The highest common factor of these 3 numbers is clearly 2. And since all these terms are negative, it's minus 6a, minus 24a, minus 4a, so I can probably pick out a minus 2 outside. And then you can see the a's are also common to all 3, so I can probably pick out an a. And then I'm going to be left with 3 here. Then I'm going to be left with a 12z here, because 12 times 2 is 24, so I'm going to be left with 12z, and then I'm going to be left with plus 2y. So that's the way I'm going to get my factorization. So so you can try doing other things. So for example, if you have a number like, maybe just experiment, if you have a number like minus 6x minus 15, and you want to factorize it, so you have minus 6x minus 15 and you want to factorize it, but again you have to first look at the HCF of these 2 terms. So 6 and 15, the maximum that they have in common is 3, so maybe you should take 3 common, and since both terms are negative, so maybe you can take minus 3 as common. And now if you take minus 3 as common, you're going to be left with 2x, and you're going to be left with plus 5, and that's the answer that you're going to get, okay? So hopefully this idea of factorization should be clear, and the way you check your factorization is that you can expand out your factorization, and you should get the answer that you started out from, okay? So Now let's play a small game. It's kind of a fun game to play, and then you can. So let's think about the small game. Here's a small game. So you have to think of a two-digit number, any number greater than 20. Then you have to add the digits. You have to subtract the digits. So you have to subtract the sum from the original number, and then you get a new number. You add the two digits of that number, and you turn out that number is miraculously 9. So let's just play that game. Maybe you don't understand it. Let's pick a random number, like maybe like 73. So if you put a number like 73, first I'm going to add the two digits. So 7 plus 3, that's going to be equal to 10. Then I have to subtract 10 from the original number. So then I have to do 73 minus 10, which is equal to 63. And now I have to add the two digits. So 6 plus 3, and that's equal to 9. Okay, interesting. Let's try a random other number. Let's try something like 46. So let's try another number like 46, or let's try 45, 47. Okay, so we have 447. So first we have to add 4 and 7. We add 4 plus 7, we get 11. So then we have to subtract 47 minus 11. If we subtract 47 and 11, we get 36. And again, 3 plus 6 is equal to 9. So it seems weird that if you follow these rules, the rules that I've just stated over here, you seem to be able to get the answer 9 always. The question is why. So I want you to mull over it and try to figure out the answer yourself. If you can't, we'll talk about it next time.